Good evening, everyone, and welcome to the Falkner Natural History Lectures from the University of Albany's Atmospheric Sciences Research Center. My name is Mark Boharnwa. I will be your meeting and lecture host this evening. I will quickly review our Zoom protocols, introduce tonight's speaker, and will moderate the post-lecture question and answer period. Tonight's presentation is the third of 4 Falkner lectures in our summer 2021 series. So before we get started, as we usually do, let's quickly resume our Zoom protocols. The lecture, all messages sent to the Zoom chat feature and the post-lecture Q&A are being recorded. Your video and audio has been disabled until the post-lecture Q&A period. You may submit comments or questions to the chat at any time. However, they will not be addressed until the post-lecture Q&A session. Please do not use the Zoom raise your hand feature until after the lecture. Any raised hands will be addressed in the order they were received, and you will be asked to unmute to pose your question. You may also enable your video if you so choose. And as usual, please remember that if you're going to ask a question, to make sure that your background noise is at a minimum. Before introducing tonight's lecture speaker, I'll play a brief video from ASRC's director, Dr. Christopher Thorncroft, providing a history of the Falkner lectures and a bit about ASRC.
And before we come to the speaker today, I wanted to say a little bit about the Ray Falkner, whose name is given to the seminar series. So in 1961, Vincent Schaeffer founded the Atmospheric Sciences Research Center and shortly hired thereafter Ray Falkner as ASRC's very first full-time employee. Ray was often referred to as Mr. Weather. From his early days as a weather observer atop Mount Washington in New Hampshire to his work at the General Electric Research Laboratory in Nobel laureate Irving Langmuir's Project Cirrus, Ray was an enthusiastic disciple of the atmosphere. Ray's boundless energy was poured into public education on weather and the environment. His popular radio weather commentaries, his articles, and his lecture series made him widely known as the voice of the ASRC. Ray initiated this lecture series in the summer of '62 at Whiteface Mountain. And in 1973, ASRC expanded the series to include a spring version on the Albany campus, which is this present series. This series is deeply rooted in ASRC's history and offers scientists a unique opportunity to engage with the general public. Indeed, we have a fantastic slate of strong interdisciplinary talks this year. And I would like to thank Dr. Craig Ferguson and his committee for doing such a great job in creating such a strong slate. Before going on to introducing tonight's speaker, I wanted to say a few things about the center for those of you who may be less familiar with what's going on these days. I just want to highlight a few of the areas that we do that are important for the society and the state and the globe. We work on air quality and atmospheric chemistry, observations theory, including many observations that take place at our Whiteface Mountain facility. We do a lot of work on boundary layer meteorology, which is basically looking at the atmosphere close to the surface and how energy, temperature, and moisture are transmitted between the land and the lowest levels of the atmosphere. We also have a growing area in applications of artificial intelligence and machine learning. We've recently deployed some quite strong computing infrastructure to support machine learning through the Excite laboratory and are contributing to a national institute, a $30 million institute in artificial intelligence and trustworthiness. We do lots of work in climate and weather, including extremes, and we also are very strong in renewable energy, wind and solar, to name but a few. Finally, just want to say that we're very excited about this summer. We are going to be moving into a new building, the so-called E-Tech building, this summer. And in this building, along with ASRC, we will be joined by the Department of Atmospheric Environmental Sciences, the New York State Mesonet, a Center of Excellence, the Excite Lab, as well as our local National Weather Service forecast office. A dream come true for bringing all of these entities together. And we will also be co-located with the new College of Emergency Preparedness, Homeland Security and Cybersecurity, as well as Environmental Engineering. A huge opportunity to promote and continue interdisciplinary research.
Tonight's lecture, The History of the ASRC Whiteface Mountain Field Station Summit Weather Observatory, is a pre-recorded lecture organized by Mr. Paul Casson. Paul is the operations manager at the Atmospheric Sciences Research Center's Whiteface Mountain Field Station. He is a longtime member of the Whiteface Mountain Ski Patrol and currently serves as vice president of the Whiteface Mountain Regional Visitors Bureau. Prior to joining ASRC, Paul worked for 13 years as a field technician for the Adirondack Lake Survey Corporation, including serving as the site operator for the cloud collection system atop Whiteface Mountain. After tonight's recorded lecture, Paul will be joined by Doug Wolf, his predecessor as manager of the facility, and they will be available for your questions.
Thank you, Mark. The presentation this evening is intended to provide a historical perspective and timeline of the development of the ASRC Whiteface Mountain Summit Observatory. I would like to take a moment to acknowledge the contributions of my predecessor, Doug Wolf. Doug led the field station for the majority of the past 50 years, and this presentation could not have been done without his contribution of materials and his invaluable institutional knowledge. The Wilmington Historical Society has also been very helpful in providing photos and video footage used in the presentation. I would also like to acknowledge the contributions of Mark Beauharnois, Senior Programmer Analyst at ASRC, and our Science Manager, Richard Brand.
Whiteface Mountain has a very interesting history. From its early visitors in 1835, Professor Emmons observed that the mountain had unique recreational and scenic aspects, but it also had a very interesting scientific base to it too, with the vegetation, the flora and the fauna that were there. So the basis was laid for looking at the scientific aspects of things and not just the recreational and outdoor activities. Over time, some weather measurements were made over the mountain, usually just incidental reports from folks visiting. In the 1909, the fire towers, the fire weather detection system was started with towers, and a ground station was established and replaced with a steel tower in 1919. And from these, some weather information was generated, primarily during the fire season in the summer months. But the interest was there to continue the program. And it became part of the development that the Memorial Highway was going to be built, proposed and started for a motor road to the mountain, one of the first roads that served for recreation basically only. same time, other universities, NYU and RPI, saw the interest in establishing a mountaintop station similar to what was on Mount Washington, and also the Blue Hill Observatory in Massachusetts associated with MIT. And so as a result, in 1937, they made a proposal to the Whiteface Highway Commission to develop and make not continuous, but quarterly hour readings there. And the observers actually live at the summit in the Castle building for that first winter as the summit facility was being constructed. They took observation data that was important for the World War II effort, the upper air atmosphere combined with Mount Washington's. They also ran a series of radio transmission projects and wind instrument calibration tests and other activities that were very basic to meteorology at the time. The program ran until 1946 and was concluded. And several other outside agencies, such as the General Electric Research Lab, working on Mount Washington and also here, visited the mountain. And among the team was Dr. Vincent Schaeffer. And he became very well connected in developing the activities at Whiteface. He was an ardent conservationist involved in skiing and the outdoor activities. And in 1957, in conjunction with the Adirondack Mountain Authority, he proposed to develop a museum of the atmosphere, which was a reestablishment of weather, but then going a step further as an interpretive center that would provide information and research information and educational information for the visiting public. And that did get established and was run for a 10-year period with very interesting measurements and situations observed. In 1957, he proposed to reestablish the station and purchased some instrumentation in conjunction with the Adirondack Mountain Authority, who were the landlords at the time. And a series of measurements were made and well received through that period. Several people associated with that at the time was Ray Falkner and Gene McLaren. They were very active in measurements there. Finally, in 1958, a legislative bill was generated to create money to go ahead and actually construct that. It was approved by the legislature and made the money available to go ahead and do some modifications to the summit, and as a result, upgrade it to handle the public better and also create a continuous weather information station, research station. Well, it went through various reviews and issues and changes and administrations, and finally, the decision was made to go ahead and get an architect, design it, and construct a facility. At the time, the original plan was to modify the summit in 1963, but all the parties disagreed and felt that it would be more advantageous to just make an addition to the existing summit, which in turn would replace the old 1919 steel fire tower, which program was ending in 1971, and incorporate a radio transmission tower that had been put in there that was not serving a very useful purpose. So that merger all came together, and each agency put in its requirements, and after several revisions by the architecture, it was decided that a round structure would be the most effective, much like on the lighthouse you see. Blue Hill Observatory has a round tower they built in 1909. Mount Washington's modification, they put in a round tower above the main building. So it would be omnidirectional for any kind of weather or wind you get coming in. And the basic structure was a farm silo, 24 feet in diameter, 30 feet high, with an observation cab attached to the top to supply, to meet any needs for fire lookout, which were not really used because Whiteface is a cloud factory that generates its own local clouds, and subsequently the observation was blinded by the local cap clouds on the mountain. So the issues and revisions went through for how to supply it. The electric issue was a major problem because the old line from 1936 was limited in its capability. As a result, when the for the power for the observatory had two circuits, one was just a general utility and the other one was a heating circuit. And so when the elevator was operating, the heating circuit had to be turned off. And when the elevator was not in service, the heating system could be used again. That upgrade didn't come until the Olympic improvements starting in 1979, when a massive, very high voltage line was run up through the ski center for the snowmaking and other activities and extended to the summit to provide reliable power. At the same time, the number of radio users were moving in, the state police agencies and the conservation agencies, because that medium was being used more and more. So there were also issues of radio frequency interference as a result of that had to be dealt with. And these things were checked and measured, and as a result, some kind of agreement was made to limit power, what would be needed for power, space, and radiation from the antennas for instrument effects. The satellite was completed or started in 1969. The shell was up on the outside, and it continued for the next summer. The cabs and parts being flown up by helicopter. They were assembled and put together, and several options were available to make access a spiral staircase up the outside, which was not put on. The fire conservation felt that this wouldn't be necessary. They weren't be manning the tower. And also a design feature of cedar shakes and a steel railing around the summit of the old building were all included in that plan, which gave an additional instrument platform to expose equipment on, which was used very extensively. One of the interesting things was that the fireplace that wasn't used in the old building had to be stopped because we were measuring condensation nuclei and air PM particles and high volume particles and gases. And as a result, the interference was there. So electric impeders replaced that. The architect for the project was Gilbert Parker from Glens Falls. Parker and Henry. Gil was a very active outdoors person and generated some of the solutions he felt would supply water to the building and also waste disposal. What he designed was to collect the condensate water that flowed down the shaft and out the tunnel during the winter months year-round, and then pump that back up to a 2,000-gallon tank on top of the building. Well, this was a good idea, but unfortunately it was not being able to be heated, and the building had to be drained and the tank had to be drained in the winter because of freeze-ups in the cold weather. The other issue we had was with the waste disposal, installed a combustion toilet, propane-powered unit, which completely polluted the whole environment. And so as a result, that got eliminated, and I went over to tried a composting system, which is not effective in a public area. And then finally, just a portable system where you pack it in and you pack it out. Some of the other issues that we ran into were the windows were designed to swing inward, so they were recessed in the building. And as a result, wind-driven water, cloud water, just went right by the gaskets inside. It was solved by simply building some storm windows to put on the outside, and the University Carpenter Shop at Albany filled that request and made them up for us out of redwood. We also made up blanks to put in so we could run air sampling lines and air intake lines out through the windows without having to drill any holes in the building. And later on, this became quite important when extensive cloud water measurements were made, where the cloud water was actually being piped inside the building to the equipment inside. Wind is an issue at Whiteface because of its topography. It has 3 ridges that force air over the mountain instead of just allowing it to flow around like the other high peaks. And so trying to get a good reading on all 3 faces was very difficult. The northwesterly winds and easterly winds were great. They were very good. But the winds from the south and southwest were injected right up over the top of the mountain. And if you read about various visitors that visited, they described this phenomena as they were sitting around their little campfire up on the top while a horrendous gale was raging 2 feet away, the air going over. So for wind measurements, it was a little tricky and not real uniform like we would wish it to be. Access to the elevator was maintained because actually the average temperature in the tunnel is 38 degrees year round, which is the standard high density point for water. And as a result, in the winter months when it was colder outside, it actually dried out and was very dry. So all the concerns from other people about condition of the elevator were kind of boundless because it was totally dry in there. In the summer months, it was condensation and cloud water seepage and other things coming down and did create problems for it. We put a series of doors and baffles in the tunnel to slow down the air. We kept the front entrance pumped out. That pitch to the shaft, into the shaft was on a 12-foot drop from the beginning to end, and the water would dam up and freeze at the door. So we pumped that out. To get up and down the mountain, we had to supply our own equipment. At one time, we were using the snowmobiles. And then in 1971, with the building, we purchased a track snow machine, a Thiokol, from the dealer at West Mountain in Glens Falls. And these were very early snow machines made in Utah and worked well. They were a year-round machine that could be used. They were good for ascent and over. They're designed to work on their muskeg conditions in the north. With snow sleds for backup, we were able to maintain easy runs. Prior to 1980 Olympics, we saw a need to increase change that machine, and we purchased a newer one, a 79 model with a grading blade on it that we could maintain the snow drifts and so on, because we knew that the Olympic demands would be great. And in 1980, the buildings were actually taken over by the New York Telephone, and all the video programming and audio program for the Olympics was fed through Whiteface, through that site. And its setup started in 79 in September. New power was put in, so things were reliable. And that was a big boost because we didn't have to use transformers, constant voltage transformers and other things on equipment. We had no difficulties. Once the Olympics were over, we began an intensive program of cloud chemistry measurements. The acidic rain deposition program, both federal and other agencies, was very extensive. And as a result, we had set up various types of collectors prior to this and testing them. One of Ray Falkner's original proposals way back was to try and estimate the amount of cloud water intercept on the mountain, but it went that way and also a step further with measuring the actual chemistry of it. So again, with seven other sites down the East Coast making similar measurements, the cloud water chemistry program was established and put together a series of data showing what areas were and what cloud acidity and measurements were telling us and happening. Also, a number of other forestry projects worked out of the station up there, not necessarily right at the summit, but looking at forest decline issues, soil issues as affected by atmospheric deposition, and which were very extensive and very helpful in determining what exactly was causing bad effects. After the Olympic period, the research sort of got jump-started in atmospheric deposition due to acid rain effects that were being projected and its effect on forestries. As a result, collectors were developed to collect cloud water. And that's a very interesting question. Well, how do you do that? Well, the first thing you probably would do is see how nature does it. When you look at the balsam trees, the needles on trees, and pine needles and so on, leaves, and spider webs, they collect water, we see them. So as a result, a series of stringed circular collectors were designed by Ray Falkner that would catch the wind-driven cloud water droplets, funnel them down into a system that would go to a pH meter for acidity or base, or further analysis too. Later, this was modified for the major big program and simplified, and so that the units were portable and could be set up in the forest, just above tops of treetops and so on to collect cloud water from those points.
We are in the Adirondack Mountains, the land that nobody knows, but the land where most of the alleged impact of acid rain is felt. We collect clouds here. We collect precipitation in an attempt to assess how much pollution-related ions arrive at this sensitive region. Being so high up in the mountains allows us to be within clouds almost half the time of the year. This obviously makes it very easy for us to catch the clouds and measure the pH of the cloud, the chemical composition, the sulfate, the nitrate, and a variety of other substances. This will then help us to establish eventually a source-receptor relationship between the gases in the atmosphere and precipitation quality that the soil eventually will receive. I think our ultimate goal is understanding where the precipitation quality comes from that we measure here, what happens to it on its way from sources to its ultimate sink, which is this mountain here, or the Adirondack at large, and to eventually come forward with a relationship that links sources somewhere in this country with the receptor area such as Whiteface Mountain. The high peaks and the Adirondacks in general are made of solid rock. This here is granite that has aged over the past 2.5 billion years. There is no way that this bedrock will neutralize the acidity that falls from the sky. So obviously it's not hard to understand that whatever acidity comes from the sky will run off in the water and will be found in the watershed. The soil that you see here is very thin. It is a very harsh climate. So if anywhere in the country do you feel the impact of acid depositions, it would be in areas such as this, where the soil, the underlying bedrock, is very sensitive to acidic inputs, where vegetation is at the verge of breaking down. This is environmental stress, as an ecologist would define it, as its best. We find that the sulfate and nitrate levels in precipitation and in clouds are almost half as much as we find in the middle of industrialized regions. So obviously, this area is impacted, and our job is to find out where it comes from. It's very difficult to find sources, individual sources. It's very difficult from this remote place to imagine that some regions far away, hundreds of miles away, can have a profound impact. Nevertheless, we do feel here that whatever we measure within this region, most of it has been transported into this region. The Adirondacks do not have great emission sources, so sulfur and nitrogen compounds must come from somewhere. Do they come from sources 100 miles away, 500 miles away, 1,000 miles away? Do they come from the southwest or from the northwest? This is still subject to heated debate. We are equipped to measure how much arrives. We are equipped to find out from what direction they came from. But at this moment, we are not yet equipped to find out where they have originated. This would be research whereby somewhere in the country, very specific tracers are released. So specific that if we catch them up here, we know where they came from. And with that information, we are a giant step closer to the source-receptor relationship. Over the past 20 years that we studied the mountain, the clouds, and the precipitation, we have not observed an increase in precipitation acidity. We have not observed an increase in sulfate levels in the clouds. To the contrary, all indications that we have are such that this general region here has experienced an improvement in the sulfate exposure. 25 years ago, sulfate in precipitation and sulfate in the air was higher than it is today. Even though the atmospheric input seems to have improved, it wasn't enough for the sensitive ecosystem in the Adirondack to appreciate that improvement in atmospheric deposition. At this time, we don't have a clear indication that acid rain is the single culprit. There are other factors that can contribute. For example, a drought can initiate a change in the soil and subsequently a change in the vegetation. I guess what makes us so concerned is that the changes in the vegetation that we see in the Adirondacks occur very slowly, very, very slowly over a period of 10 to 20 years. These are not the changes where you would walk in today, look at a tree, and then come back a year later and say, here, see a damage. That at the same time makes it obviously so hard to focus on as far as our efforts are concerned to see whether the atmosphere, the soil, or a combination of everything caused the change that one observes. Sitting up here on top of Whiteface Mountain and watching the world, one certainly would like to see the air cleaned up. The options to do so, however, without compelling reasons from the point of view that there's a health hazard or an imminent ecological damage, those should come from not only environmental concerns, but also from economic concerns. We just cannot go out without substantial proof and request a improvement in the atmosphere because there is suspicion that this atmospheric composition does harm. We must have a bit better understanding. We must have a better understanding of source-receptor relationships. So in lack of that better understanding, one should look for solutions that are not only environmentally desirable, but that are also economically desirable.
And interestingly, a number of countries use cloud water to generate drinking water for their there are islands and there are other areas where they have abundant clouds, but not a sufficient water supply. Once the cloud droplet situation and cloud chemistry was studied, the next thing was what's in these things. And so efforts were made to try and understand the real pollution, which is the particulate matter. And a variety of instruments were set up to measure the different diameters of particulates in the atmosphere, ranging from very, very small all the way to very, very large dust particles and other things. Again, having a station lower on the mountain, we're able to collect these particulates below cloud level as well as in cloud level. And we found some very interesting things that happen.
Over 1 million acres in the Adirondacks are above 2,000 feet, and they're often bathed in these low passing clouds. We're on our way up to the top of Whiteface Mountain at the moment to an atmospheric research station where we can actually capture one of these clouds and see what's in it. And we're about to enter the elevator that will take us to the summit. Hi, Dan.
Hi,
How are you today? I'm good. I'm good.
That's good. Let me close this door.
Hey, Paul. How's it going?
Good, how are you?
Good. Great. What's happening up here today?
We got a little bit of zero drift on the Gerber,
Oh, I
so
can
we're
see
going to have
that.
to calibrate that again.
Whiteface is an ideal location for this monitoring station because as one of the high peaks in the Adirondacks, clouds traveling from the west are intercepted here. Paul Casson is in charge of operating the equipment on the roof of the research station.
The instrumentation on the roof is sensing the presence of a cloud. When cloud presence is sensed, the collector is deployed. The cloud is blown through the strings of the collector. It condenses on the strings. Gravity draws the droplets down the strings into a funnel through this tubing and into the accumulator.
A major source of these acids is pollution from coal burning plants in the Midwest, carried to the Adirondacks on prevailing winds. On a day like today where it's very windy, you could easily understand the concept of air moving over hundreds of miles to get to you, to get to your lungs, to get to the trees, to get to this summit. And what isn't always in people's minds is the idea that where you're standing today and what you're breathing at the moment could have been air in Chicago yesterday. It could have been 2 days ago in San Francisco and 3 or 4 days ago on the Gobi Desert of China. So while air pollution and acid rain affect us here in the Adirondacks, these are really global problems that need global solutions.
The ASRC Whiteface Mountain Field Station is well positioned to leverage our past successes in advancing the state of the science going forward. Many of the research and monitoring efforts conducted at the field station in the past have been related to acid deposition. Significant reductions in acid deposition have been realized due to legislative policy based on data collected here at Whiteface. These reductions are detailed in the current slide. The successes in pollution reduction have led to corresponding reductions in funding opportunities for acid deposition monitoring. Fortunately, some of the same data collected for use in acid deposition studies can also serve as baseline data used to observe other environmental changes that may be occurring due to a changing climate. In particular, the radiative role of clouds in regulating climate remains a fundamental challenge in modeling future climate. It is my belief that in order to be truly successful, we need to involve the local community in the work that is conducted here at Whiteface, and more broadly at ASRC and the University at Albany. Most members of the community value the resources that exist in their own backyard. Taking pride in your community is critical in fostering public support needed to encourage policymakers to provide researchers with resources to conduct their work. Perhaps the most critical element in ensuring the continued successful operation of the ASRC Whiteface Mountain Field Station is our collaboration with the New York State Department of Environmental Conservation. Since the creation of the field station in 1961, DEC has been our most important collaborator, and that relationship continues today. In closing, I would like to reiterate my desire to continue to develop and enhance our close working relationships with our research partners here at Whiteface. In my opinion, this is the only path forward that will continue to produce the high quality, long-term data sets that have made the ASRC Whiteface Mountain Field Station what it is today. With continued support and guidance from the University at Albany, the future of the field station looks bright. Thank you.
Okay, so with that bit of history on the Summit Observatory and all the operations at Whiteface Mountain, I'd like to now open the floor for some comments and questions from our audience. As I mentioned before, both Paul and Doug are available to address your questions and comments. So Paul, I'll ask you to unmute just so that you're ready. And hopefully now with our audience, we'll have some intriguing and insightful questions. So you can either pose a comment or question in the chat, or if you'd like to use the Zoom raise your hand feature, you're certainly welcome to do that. And we will keep an eye out for anyone who raises their hand. So I guess I'll ask the first question then. It's actually a question for Doug. What's that, Paul?
Nothing. Go ahead. He's ready.
Okay. Actually, it's a question for Doug. So I was kind of curious about the portable toilet situation, the pack it in, pack it out. I was kind of wondering if that's where the Adirondack, signs pack it in, pack it out came from, was from the operation at Whiteface.
Well, it's a short, easy expression to remember on it, but
okay.
In that kind of a situation, you're really limited. We were actually had complaints that we were dumping raw sewage on the side of the mountain up there, when actually it was just the tunnel wastewater, gray water, and all the good stuff was packed out of there.
Oh, okay. Anyone else have any comments or questions for either Paul or Doug? Want to make sure we give our audience a chance to give everybody a chance to think for a couple of minutes. We wanted to give you a historical perspective as far back as we could. We've done some presentations and lectures on some of the current work that's happening, and there'll be more to come with new lectures on some of the revitalized research that our faculty and scientists are working on here at ASRC and the university. So you can certainly look forward to those. But in terms of hands-on history, we really appreciate having Doug help us out here and remember some of the things that.
Are we still muted or not?
Oh. No, you're live.
Well, there's a few people listening that I'd like to acknowledge. Ron Stewart is one. He was our key man on the Albany end that keeps things going, where you really have to have the contact, interaction with Falker and the others. So Ron was a very key guy in it. He did some of the early solar energy work here with UNESCO, and they had a program of helping the developing countries pump water using solar panels. So today we can see the many countries use his methods that he was instructing in that class. Alice Pelsey is a longtime employee there of the ski center. She was very helpful in the office over there for maintaining logistics and things too. So we'd like to acknowledge them.
Hi, Doug. Ron Stewart. How are you doing?
We're doing good. Old, but good.
You're a few years older since the last time I saw you. I was
Yeah.
going to ask, Doug, when did you start at Whiteface?
I was actually in high school. It was in 1962. In that time frame, I had a connection with one of the research, the single research was being done here. And they decided they were going to run, Ray was going to put together a program through the winter there of 62. He had a postdoc that was sent out to the lake effect storms on Lake Ontario. And so he asked me if I would be interested. So my dad drove me where I needed to go to up here to Marble and get readings. And then also at the ski area, they took a reading at 4 o'clock for Ray's radio program. So that's kind of about it. So the official payment was like $15 a week.
Well, you can get that every hour now. But anyway, if things work out, I will be speaking to Falker tomorrow morning. So I'll let him know that you've been on TV.
Yes.
Yeah, it's he did a lot of good things for the station to keep us going, as that was shown in the video. Yeah.
Yeah.
Yeah,
Falker,
Ron, please say hello to Volker from all of us.
Yes.
be happy to try to do that. Yeah.
That's great. Hopefully that'll work out. So while people are thinking about their questions or comments, Doug, I have another question. It's related to the 1980 Olympics. Can you just kind of give us a quick overview of the experience with that and the synergy between the field station and the Olympic process?
Well, that really started in 1976 when Lake Placid was submitting the bid for the Olympics. They asked for meteorological data, and so I had put that package together for them. Then as it proceeded on, they got awarded it. Again, became apparent that some new technologies were going to be used. The microwave systems, fiber optics in Lake Placid in that area was brand new and used. And so Ron can probably fill you in on the details on the administrative end, but we basically surrendered the whole building to New York Telephone in the fall of '79. They had 43 channels of microwave coming and going. Everything that was at the venues, Whiteface and the outer Olympic Village were all shot by video to the summit and then down to the broadcast center at the Lake Placid Airport. And then back up to the summit and on out to the various global organizations, Japanese NHK, ORT, the Dutch, all of them. So it was a very important station for that. There's a lot of early science too. Now it's very common for satellite transmission, but everything went down to Maryland and was transmitted up to the satellite. And Ron and Ray Falkner put together a lecture series for that to support our support in it, to give the athletes and the support people some options for different things. The crew actually stayed at the summit. One of them made paintings up there on the off time, and it's very interesting. And a number of other people came up to visit, press crews and things like that. But it was, and then the weather really cooperated. There wasn't really severe weather at that time. And so the skiing was all done on man-made snow, so they didn't really need natural snow. So the transportation issues were not too bad at all. We were able to actually four-wheel drive most of the summit that year. So it was the last small Olympics there was. After that, everything's gone mega levels. And so it was a nice hometown Olympics.
Yeah.
If you remember, we did a photovoltaic system on Little Whiteface, and we ran 3 communication systems on photovoltaics. That was sort of first for anybody.
Right. Yeah, that was very early science on all of that. Now it's so common. It's not even recognized.
It's in the backyard now.
Yeah, I can imagine. Well, I don't, as you might know, Ron, and I'm sure Doug knows, but in January of 2023, the World University Winter Games are coming to Lake Placid. Not Olympics, but the university games. And so there's a lot of infrastructure being put into Whiteface and the surrounding area in terms of buildings and power infrastructure. So there's a lot of exciting things happening up there. We're trying to have some synergy and have ASRC / UAlbany involved in that in some capacity, but there's a lot of logistics that still need to be worked out. I think it would be a great visibility opportunity for both ASRC and the university if we could somehow be involved in that.
Good.
So how about anybody else? Any other comments, questions for Doug or Paul at this point?
Peter's just had one in the chat box.
Okay, I'm Karen Peters. Yes, I answered that through the chat. Her question was, oh, I'm sorry, there's a second one. Where does the funding for the ASRC come from?
So I can speak to that. Rich, our science manager, his funding comes from NYSERDA. DEC owns this building, and so we have a memorandum of understanding with them to use the building. My salary is a state item, and some of the other research up here is being funded by the National Science Foundation. So it's kind of a influx things, but NYSERDA has been our largest funder of late. Yes, New York State Energy Research and Development Authority.
That's a great question, Karen. Thank you.
Just a question for Mark, if I may.
Of course.
Can we see the previous programs on some system at the university?
When you say previous programs, you mean the research programs that have been conducted?
No, I'm talking about the last 3 Whiteface Ray Falkner lectures.
Oh, yes.
Just like tonight. Does this get
Yes.
copied someplace?
Yes, for the summer series, all the spring series are out on the YouTube channel.
Okay.
And we can put that link in the chat. The summer series, I've been very busy. I haven't had a chance to get those out there uploaded. Part of the process, Ron, is I have to make sure where possible, they are web accessible to the hearing impaired. So I have to go through the transcript and make sure everything is correct. So it's kind of I'm looking for a student to be able to help me do that. So I'm a little bit behind for the summer series, but in a few weeks, hopefully that'll all be updated and we'll send out a mass email to everyone when that happens.
Thank you.
You're welcome. So with that, if there's no other comments or questions, I'd like to thank both Paul and Doug for the work that they put into this. Thank you, Hector, for putting the YouTube link in the chat. So again, Paul, thank you, and Doug, thank you for your time and energy and all the resources that you provided for the background and the history. It's invaluable information, and it's something that I look forward to watching over and over again. I love hearing your stories and the history behind your work and all the great things you did while you were the site manager at Whiteface. So really appreciate that. And we hope to see everyone for our next lecture in a couple of weeks. And we will try to send out a reminder email for that. And with that, we thank everyone who has attended, and we thank again Paul and Doug.
And thank you, Mark,
Thank you.
for all your work on this. And thank you all for taking the time. I appreciate it.
My pleasure. It was my pleasure.
Good evening.
Take care.
Good night.